Hello, my dears. This is week 2 in module 1. And this week we will study the evaluation of error and measurement. Principle of instrumentation and measurement. Let us define measurement here. Measurement is the process of obtaining the magnitude of a quantity and compare it with agreed standard by using the proper instrument. Basically, we are using the measurement for the purpose of monitoring, controlling a process. Before I proceed, let me just go back to the measurement. In measurement, what he mean by obtaining magnitude of a quantity. Like for example, if I have a piece and I want to find its length. So the quantity to be measured is the length. And when I want to relate it to agreed standard, that means I want to put certain unit for it. So I am going to put the unit is something in centimeter. The unit is centimeter. Okay, and the instrument to be used for that is the caliper. Okay, so that's how, or that's what we mean by the measurement definition there. The major problem in measurement is the error. So error is the major problem in measurement. So that, therefore, when we want to measure, we need to look for the right instrument, the appropriate instrument to get the error to minimum. So we cannot eliminate error, but we can make the error minimum. So we use the right instrument at the right location to get the error to minimum. To avoid error or to minimize error in the measurement during the experimental work, something to be taken before measurement, during measurement, and after measurement. What to mean by that? What to be taken, or what should we care about before measurement? Before measurement, we should care about the method of doing the measurement and the characteristic of instrument. So we need to know how to measure. We need to know the characteristics of the instrument we are using, whether it's suitable for this kind of measurement or not. And then quality, time, and cost of the instrument. So all of these things, we need to keep them in our mind before we start the process of measurement. So now during the measurement, we are supposed to take care of the quality. It means I'm supposed to select the best instrument and take the data at the right situation or the right position. It means doing the measurement at the right position. And now the safety is keeping the man safe and the instrument safe as well. Safe against electric shock or overloading of the instrument or exceeding the limit of the instrument. To take care of these things, we are supposed to read the instrument manual before we start the instruments, so that during the instrument I am using it in the correct way. Then sampling, I need to decide how many data is to be taken. I need to how many sample to be taken, how many times I need to repeat the measurements so that I can get enough data to make sure of minimum error. After the measurement, after the measurement, we need to take care of the analysis of the data mathematically using the right way of analyzing the data. And a full result must be prepared completely and accurately. So if I am analyzing the data correctly, that means I'm going to get the right result or a full result, and the right result which accurate enough for my measurement. The value we are obtaining by measurement is considered as approximate value, not accurate value. If we are doing the measurement for the same parameter 2 times by the same instrument, we may get 2 different values. That's why whatever we are obtaining is approximate. So how to get the accurate value? The accurate value can be obtained by analysis after that, after the measurement. So we are going to do an error study which will tell us the accurate value. What is error now? If I defined error, Error is the difference between the true or actual value. I mean, we have actual value or true value. The difference between that value and the measured quantity. Remember, we are doing the error of measurement. So the measured value is compared with certain quantity. That quantity is known as the true or actual value. Where to get this true or actual value? The true value is the value of the average of infinite data collected. Means let us assume that I am measuring that quantity for infinite times. The average of those measurements is considered as the true value. Or actually, we can say it's to be obtained by calculation. The value of calculation is considered as the true value. Absolute error. Now let us put it in a form of formula. As I said, it's the difference between expected value of the variable and the measured value. Expected value is the value which we are expecting, which we know from the calculation. And the measured value is the value we are obtaining by measurement. So we can put them as the error is the absolute of xn minus yn, where xn is the expected value and yn is the measured value. Absolute error in percentage means if I want to express the error in percentage, it's going to be found as E, which is the error, over xn divided by 100%. Now, how about the relative accuracy? Remember, error and accuracy is one of them is opposite to the other. How about accuracy? Accuracy is 100% or 1 minus the relative error. So 1 minus E over xn, where 1 is the full quantity or the 100% minus the error. Okay. How about the accuracy in percent? It's whatever we obtain in A multiplied into 100%. So this value multiplied into 100%, or we can say A, which is the accuracy in percentage, it's 100% minus the percentage of error. So we can obtain it by either way. Or as I said here, it's equal to A minus 100%. Let us look at this example to understand the definition of error. That's it. The very simple example, just telling us about the definition of error. He said here the expected value of voltage across a resistor is 80 volts. So we are expecting 80 volts. Where we get this 80 volts from? It's by calculation. Sometimes we obtain it by calculation, or some data, some analysis tell us that the voltage here must be 80 volts. When we measure it here, let's see. However, the measurement gives a value of 79. So we are expecting 80, but we are getting 79. What is the absolute error, percentage of error, relative error, and percentage of accuracy? Relative accuracy and percentage of accuracy. Absolute error, by definition, is 80 minus 79, which equal to 1 volt. To get the percentage of error, it's yn or minus xn over yn into 100%. Okay, means actual value minus error over actual value multiplied into 100%. We are getting 1.25%. So this is the percentage of error. How about accuracy? Accuracy, as I said, we can obtain it by two different ways. We can say A is equal to 1 minus yn minus xn over yn, which equal to 0.9875. That's the accuracy. If I want to put it as a percentage, you multiply it into 100. When you multiply it into 100, it's 98.75. The other way to get the error, the accuracy, remember that the error here was 1.25%. 100% minus 1.25% will give us the same value. That's the other way of calculating the percentage of accuracy. Types of error in measurement. There are many types of error in measurement. As I mentioned earlier, error is certain parameter to be studied to eliminate it, but by analysis, not by measurement. So we will do the measurement, and through the analysis or through the study of the error, we will eliminate those errors during the analysis. Now we will start by defining the error or look at the source of error. In the type of error, we have gross error. A gross error caused by the human mistake. Like what? Like incorrect reading means there is error because we are not reading correctly. Why the human is not reading correctly? Because he's not having full knowledge of how to measure, or maybe there is something not clear in the environment of measurement. That's why he cannot get the right measurement from the device. Or sometimes he is measuring correctly, but when he he didn't record the measured value in the right way. How to minimize that kind of error, or how to reduce that error? Not to eliminate, we cannot eliminate, but we can minimize only. How to minimize? Take at least 3 separate reading. Means I supposed to read the same parameter 3 times, minimum 3 times. That's the way. Later I will find the average out of these 3, and we have to take care during the reading. We have to take care. I mean, we read carefully. We put ourselves in the right situation to measure correct as possible, or to make sure that our reading is correct. Then when we are recording those results, we have to make sure that we are recording the result in the right way. The other type of error is systematic error, where systematic error is having 3 types. We will start by instrument error. So under systematic error, we have instrument error. What is that? It's the error due to incorrect spring tension. Mostly this one for the electromagnetic or the meters with a moving pointer. For the meters with moving pointer, because with the moving pointer there is a spring having certain tension for that spring. So by using the device, the spring tension may have some problems. So that's what he means by incorrect spring tension. It's due to the usage of it, the spring will not have the same tension as it was at the time of manufacturing of the device, I mean. So here it's incorrect in the meter movement that's causing the problem in the spring, and improper calibration. Like some devices, we are supposed to do calibration for them every 1 year or 2 years. If we are not doing the right calibration, we may have that kind of a problem, which the incorrect spring tension. Or fault instrument. So there is fault in the instrument, means the problem is the instrument is having a problem. It's having some problem in its operation, so it needs maintenance. To minimize this kind of error, we need to do a proper maintenance to the device, to the instrument, and proper use and handling of the instrument. We are supposed to use the instrument in a proper way. Systematic error is due to environment, or it's environmental error. It's due to external condition of the measuring instrument. Due to the external condition of the measuring, it means here the measuring instrument. That means the measuring instrument is prepared to work at certain temperature, for example, or certain pressure, but you are using it in different temperature or different pressure. Like for example, if we are having a meter which is supposed to work in a temperature of 25 degrees Celsius, for certain reason the temperature increase to higher than 25 degrees Celsius, so that there will be high chance of getting error in the reading out of that instrument. How to minimize that error? How to minimize this kind of error? It's by putting the error in good environment, like using it in air condition. If it's sensitive to temperature, for example, we put it in air condition. Strong sealing for the instrument to avoid any dust of going inside it, because it's going to affect its measurement. And using magnetic shields, because sometimes some instrument is affected by the magnetic field. So we put shield to take this magnetic field out of the device, not allowing it to affect the device. Number 3 is a systematic error, which introduced by the observer. View the meter reading scale. That means the scale of the meter cannot be seen clearly by the observer. It's due to maybe the dusty environment, or maybe the screen of the meter is not clear due to aging. So the observer cannot read the value correctly, which will result in error in the measurement. Or error of estimation, because the observer, if you look at this figure, for example, when the observer look at the value, he cannot decide exactly whether it's at this location. It's going to be this location if you look from this angle, or it's going to be maybe this value if you look from this angle, or this value if you look from this angle. So the angle of looking at the meter may give wrong result to the reading. So that's going to cause error in the measurement. Type C is random error. It's the remaining error, or the remaining type, after considering a gross and systematic error. Means whatever not a gross error and not systematic error is considered as a random error. Whatever not gross error, not systematic error, considered as random error. Now, it's accumulation of many small effects. So random error is due to unknown reason. Actually, as I mentioned here, it's due to unknown cases, and it's due to many reasons we have this kind of error. So we can do it statically. So by statistics, we can avoid this error. It's not to be done during the measurement. It's to be eliminated or reduced after measurement. After measurement, we can deal with this kind of source of error.